So the purpose of factoring, guys, is so that we can solve an equation that has an exponent of 2 or more. And so for numbers 1 and 2, for example, someone has already factored it for us. So they've kind of done the hard part. And so when we're solving, we always try and get our equations to set equal to 0. And so you have to remember our zero products property. Anytime I multiply something by 0, I get 0. So basically what I'm going to do is I'm going to take this 2d plus 6 and I'm going to set it equal to 0. And then the 3d minus 15, I'm going to set that equal to 0. And the reason for this is because I'm going to get 2 answers for the variable d, such that it makes this 0, that whole set of parentheses 0, because then it'll multiply by whatever this is and get 0. And then I can also figure out what d would have to be to get that second set of parentheses to be 0, and then multiply by the first one. So I don't know if that makes any sense, but let me try and show you what I'm going to do here. So I got the 2d plus 6 is equal to 0. So now I can just go ahead and solve my two-step equation. Subtract 6 to both sides. Then I'll go ahead and divide by 2. I'm trying to fit that in there. So one option for d is to be equal to negative 3. So if I were to, hold on a second, let me go ahead and erase this the top part for a second here. If I were to substitute in negative 3 for d, right? So 2 times negative 3 would be negative 6, right? Plus 6 gives me 0 in that first set of parentheses. So let me just change my color here. So this would then be 0. So then if I were to plug it into the second set of parentheses, that would be negative 9 minus 15. Okay, so that gives me negative 24. But I don't really care because it's going to multiply by 0, which gives me what I want, which is equal to 0. So that's why I get that d is equal to negative 3 as one option. But then I'll go ahead and I'm going to solve 3d minus 15 is equal to 0 as well. So I'll go ahead and I'll add 15 to both sides. And so I get 3d is equal to 15 divided by 3, and d is equal to 5. So I get 2 answers for one variable. D can either equal negative 3 or it could either equal positive 5. So same idea. Let me just kind of erase what I've got going on up here. So now if d is 5 and I were to substitute in that value for d, so 2 times 5 is 10 plus 6 is 16. Okay, so my first binomial would turn out to be 16. But if I plug that into the second one, I know that 3 times 5 is 15, right? 15 minus 15 gives me 0. So when I multiply 16 by 0, it gives me 0. So again, my final answer is both negative 3 and 5. So looking at number 2, let me first just go ahead and erase number 1 because I just want more space. So just your screen isn't overwhelmed by my writing. So in number 2, same idea. They've already done the factoring for me. So I'm going to take those 2 polynomials, the 3n and the n plus 2, and I'm going to set it equal to 0. And so the 3n, all I'd have to do is divide by 3, and I know that n has to equal 0. Or down here I would subtract 2, and n could also equal negative 2. So again, whoops, didn't mean to next it. If I plug in 0 for n, well, 3 times 0 is 0, and then 0 plus 2 is 2. So I'm doing 0 times 2, which is 0. Or I'd be substituting in the negative 2, so let me just erase my stuff up here. So I know that 3 times negative 2 is negative 6. And then if I were to plug in negative 2 in here, so negative 2 plus 2, well, that's 0, right? Well, negative 6 times 0 will give me the 0. So looking at 3, so now 3 is not factored, okay? So my objective before I can start factoring is I need to get this to be equal to 0. So I need to move that 3c over to the other side. So I'm going to actually subtract 3c to both sides, and I get c squared minus 3c is now equal to 0. Okay, so now I only have 2 terms. So my only option in factoring is factoring out a GCF. That GCF is c. So when I factor that out, that leaves me with c minus 3, and the whole thing is equal to 0. So now I have, now basically where I was at with numbers 1 and 2. So I can take the c here and set that equal to 0. So that's really easy. There's my first answer. And then I'll take the c minus 3 and set that equal to 0. And then I'll add 3 to both sides. And so that means c can also equal 3. So my answer is c is equal to 0 or 3. So then in number 4, what's nice is it's already onto one side. So I can just go ahead and factor out my GCF, which is 8, and a b. So that leaves me with b minus 5. And that whole thing is equal to 0. So then I'll set 8b equal to 0. And then b minus 5, set that equal to 0. So here, I really should have written that like further down, shouldn't I? I need more space. So b minus 5 is equal to 0. So for up top, all I have to do is divide by 8, and so I know b is equal to 0. That's an option. Or down below, I'll add 5 to both sides, so or b is equal to 5. And then for number 5, notice how I need to get all my terms to one side, so I'll go ahead and add 10x to both sides. And so now I get x squared plus 10x is equal to 0. Now I want to factor out a GCF, which is x. I'm left with then x plus 10 is equal to 0. So then I'll say, okay, x is equal to 0, which is nice. There's my first answer. And then take x plus 10, set that equal to 0. Subtract 10 to both sides. X can also equal negative 10. So those are my two answers. And then number 6. It's already set equal to 0, so that's nice. So I can go ahead and just factor out a GCF, and that GCF would be 5 and a p. That leaves me with 4p minus 3 is all equal to 0. So I'll take the 5p, then I'll set that equal to 0. Divide both sides by 5, so I know p is equal to 0. That's one option. And then I'll do 4p minus 3 and set that equal to 0. I'll add 3 to both sides. And I get 4p is equal to 3. And then I'll divide both sides by 4. And I get p could also equal, now you can change it to a decimal, which would be 0.75. Or if you want to leave it as a fraction, that's fine. But either one is a correct answer. So your final answer would be p is equal to 0, or I'm going to use the fraction 3/4.